Hi everyone. As I mentioned in my introduction, what we'll be discussing is form, space, color, and value. This is the last, let's say, installment of the elements of design. Form. Form is the shape and structure of something as distinguished from its material. Form suggests that a reference to both internal structure and external outline, and the principle that gives unity to the whole. Um, in architecture, architecture form is the point of contact between mass and space. So architectural forms, textures, materials, modulation of light and shade, color all combine to inject a quality or spirit that articulates the space. So the quality of architecture will be determined by the skill of the designer in using and relating these elements, both interior spaces and the spaces around buildings. So since we are in the course of built environments, the margins or the limitations in where architecture and interior and landscape will always be a collaborative effort. In interior design, form, in other words, relate to the physical aspect of anything that is three-dimensional. Forms can usually be described as either geometric or natural. Geometric refers to the hard lines and square edges, often looking man-made, while natural relates to more organic forms that seems to be created by nature. One of my favorite architects that deals with organic forms is Antonio Gaudi. He's a Spanish architect with very monumental architecture and interior forms that translates, or for an example, you have your Sagrada de Familia and Casa de Mio. So another example, this is a photo on your right. This is a combination of your geometric hard lines in relation to the accented organic forms. So you have the very linear approach of the ceiling and up to your structural elements with an accented undulation of the walls as presented here. So another thing to take into consideration with form is the proportion and scale of the room to compare to the objects being placed with it. So as you can see in this photo, this interior representation, that the undulation of this wall is actually proportioned in the way that proportioned to the scale of the living room. So as you can see, you have a wide living room. Instead of clamping up with furniture, you create this very vast interior architecture treatment that actually brings softness to the space. So adding forms of similar shapes can create harmony and balance, while adding too many differing shapes can have a confusing result. So a space is typically more pleasing if the dominant form is repeated in minor objects throughout the room. So, given this example, we have a play on geometric and organic forms. So the play on the organic form here is somewhat constrained or restrained to this area, and it's also reflected in finer details such as in light design and in the, let's say, the form and the structure of the furniture. So as you can see, the furniture is very linear in approach, and you have like little bit of accents of the roundness or the organic shapes and the form. So form often includes a sense of three-dimensional mass or volume. Shape refers more specifically to the essential aspect of form that governs its appearance. So the configuration or relative disposition of the lines or the contours that limit a figure or form. So shape. The form shape is the characteristic outline or surface configuration of a particular form. So shape is the principal aspect by which we identify and categorize this form. So as discussed in the previous presentation, so you have the form. This is the form of a square. So you have it in a shape which would be there on a box or a cube. So you have your shape of a triangle. So when regards to a configuration of the form, so you have the pyramid of that of a form. And in addition, so you have the circular or the circle shape and then you develop then on with a spherical drawing. So size. So the physical dimension and length, width and depth of form, while these dimensions determine the proportion of the form. So while these perform, its scale is determined by the size relative to other form in this context. So whenever you think about the size, and in comparison to that, you have to assess it as a whole. So we assess this as a whole. So you have varying sizes, depth, and height, and form. So with this one, in comparison to the the square or the shape next to it, there is a difference in scale and in size. Next to it, so you have a difference in height or the length, and a difference in the depth and the form. So this comes off as a very columnar shape. The next would be more, let's say, mass, heavier mass on the bottom, so makes it low and visually smaller, but the ground or the plane is actually that equal to the first shape. And the next shape, so this would actually have a different perception with regards to the fourth shape. So it is more vertical in approach. It has a wider or a bigger surface area up front. So form varies in shapes and sizes. So at least you have, for us to have an understanding, you have to compare how it relates to one another. So for color, so a phenomenon of light and visual perception that may describe in terms of individuals' perception of hue, saturation, and tonal value. So I think this will be further discussed in your visual communication with regards to the light, the color, the shade, and the shadows. So color is the attribute that most clearly distinguish a form from its environment. It also visually is a visual weight of a form. So in your first shape, or in your first form, so you have the cube in all bare surface. So for this, it doesn't have or doesn't cast any shadow, or it doesn't have light or shadow. So it's visually equal on all ends. The next photo, so you have slight. So maybe we can, let's say, present a diffused light in this situation. So you have light all over, or maybe a concentrated light on this end, casting a lighter tone to the surface above and the side, while casting a darker shadow here at the back. So this also visible in the last cube. So as you can see, that the light is reflecting on the topmost portion or the surface, and then bringing on a little light onto the sides. So this area sends or perceives to be a darker area. So, and then we'll be moving on to texture. So the visual and especially tactile quality given to a surface by the size, shape, arrangement, and proportion of the parts. So texture also determines the degree to which the surfaces of a form reflect or absorb incident light. So in any form or um, So in continuation to texture, so as you can see in the first cube, there is an absence of texture. Therefore, we don't have any visual cues or visual textures. On your second cube, you have a texture or a pointed texture that might be related to sand. So with this, it is also reflected through texture, the light, or in which the degree that the surfaces accepts or absorbs light. So in this, you have, let's say, you have a light directing to this. So the surface top will have the most exposure to light. Therefore, it will be reflected as to having a lighter or a more sparse texture compared to that of the sides. So given that this would be the darkest portion of the cube, therefore you have or it entails a more compact or more textured visualization. On your third cube, so you have a, a row of linear points or lines to show or to indicate the texture of the cube. So given we have a source of light that's coming from the left corner, so you'll have it will be reflected in this manner. So the the light will be absorbed or will be reflected up to the topmost portion of the form or the shape, therefore casting little or limited light on the sides. So given this has more let's say close knitted lines or closely drawn lines, will give you the impression that this received the less light out of these surfaces. So for position, so forms also have relational properties that govern the pattern and composition of elements. So position, so the location of a form relative to its environment or the visual field which within it may seem. So this would actually vary in the positioning of your object or the positioning of the shape. Also, you have to consider the orientation. So this is very well depicted in perspectives, in your orthographic drawings, in your freehand sketches. So basically, what you will be drawing is what is in your line of sight, or that's human perception or human perspective. So orientation, the direction of a form relatively to the ground plane that compass points, other forms, or to the person viewing the form. So with this view, this is um, basically viewed on the upper portion, or so you'll be looking down towards the object. Therefore, you'll be having a very visible view of the topmost surface. The next cube. So this would actually signify or actually gives out that this is within the line of sight. So whenever there is a straight or a diminishing line, like center to your view or your perception, this would be the let's say this would be your view, or this would how you would perceive the line. So this is similar to the second. So this one is an angled view or an angled depiction of the second, and then the last would be your um front view. So this would be the dead center, therefore depicting the actual shape and not the perspective of the shape. Okay, so with visual inertia, so is the degree of concentration and stability of the form. So visual inertia of a form depends on geometry as well as the orientation relative to the ground plane, the pull of gravity, and our line of sight. So with this form, so the first form, so you have the object that is grounded in the plane. As you can see, it is resting well on the ground it lies. So um, all of the properties of form are reality affected by conditions under which we view them. So when we talk about visual inertia, it depends on the perception of the viewer. So in the second, so this could be a form that is rolling over. So therefore, there is a disposition as to the positioning or the orientation of the object. It also so maybe we can perceive this as the cube rolling over to different shapes or planes or different levels and planes. So as you can see, this is a different level, and a level, and a different level. So with this one, so the next, so this is a different view of the stability of the form. So this would actually pertains to action. So a changing perspective or an angle of a view presents different shapes or aspects of a form to our eyes. So this is um, where development comes in. So whenever you look at an object, when you turn it around or you see it in a different perspective, it actually shows different sides of it, and you have a different visual understanding to it. So our distance from a form determines its apparent size. So the lighting conditions under which we view a form affects the clarity of the shape and the structure. So sometimes, whenever I think this is very notable in art or in sculpture, that in certain areas you get to see the design in a different angle or understand a different formulation in when it comes to composition and construction. So the visual field surrounding a form influences our ability to read and identify it. Okay. So, surface. So, in the transition from the shapes of planes to the forms of volumes is situated in the realms of surface. So, surface first refers to anything, any figure having dimensions such as a flat plane. So, the term, however, can also allude to a curved two-dimensional locus of points defining the boundary of a three-dimensional solid. So, there is a special class of a latter that can be generated from a geometric family of curves and straight lines. So usually in architecture, in design, and in product design, so there is this design which is parametric, given you have certain forms that be varied through a single plane. So these are examples of parametric design that hopefully we can um, dealt with in the following discussions. So for primary solids, so okay, so primary solids. So sphere, a solid generated by the revolution of semicircle and its diameter, whose surface is at all point equidistant from the center. So a sphere is a centralized and highly concentrated form. So maybe later on, when you're doing your visual communications class in sketching, so having the sphere, so when light is cast onto it, it doesn't have the solid, let's say like this, you don't have the solid shape, so it actually casts, since it's a three-dimensional object, it casts different shadows upon where it's lying or where the light is directed. So for example, the light here is directed from the leftmost end, so you can see that the light reflects on this plane, and then it depicts a darkened or a shadow here at the back. So from any viewpoint, so the so at any viewpoint, it retains a circular shape. So um, with the sphere, so it is a self-centering and normally stable in its environment. So for example, you have the ball, your mga julin or your marble na toys or anything that's circular of the matter. So it's, you can see or you understand that its composition is usually stable when it's placed in a space, unless it's in a slope where it will roll, Jud. So cylinder. So cylinder as a solid generated by the revolution of a rectangle about one of its sides. So a cylinder is a centralized about the axis passing through the center of its two circular faces. So um that of a cylinder is similar to that of a rectangle, so along this axis it can be easily extended. So the cylinder is stable if it rests on one of the circular faces. So it is same, it has the same idea with the sphere. So once it rests on an even plane, it won't move or it won't roll, so that is its stable end. So once it is placed in a slope, or let's say you have a slope or an uneven surface, it will naturally roll. So so next you have your cone. So it's a solid generated by the revolution of a right angle about one of the sides. So I think you'll have a better understanding when you're doing 3D modeling of shapes. So how the form of a triangle will then be it will revolve around the circle to have this shape. So, like the cylinder, the cone is highly stable when it's at this resting form. So, this would be the plane. So, this would be the stable form of the shape. So, whenever you turn it, So it will topple over given unless it's on a spinning motion like when you have with your tops, or what you call that, like Beyblade, or what you, fidget spinner or something like that, that it it cir- it circulates or it's overturned. So you'll have this let's say inertia or something that would actually keep it stable at this point. So pyramid. So pyramid is a polyhedron having a polygonal base and triangle faces meeting at a common point or vertex. So the pyramid has properties similar to that of a cone, given it has a flat surface here. So because of its surfaces are flat planes, however, the pyramid can rest in a stable manner in any of its sides. So whenever you overturn the pyramid, so any base would actually be straight, so it will lie flat on the plane. So in any siya. So okay. And then your cube, so a prismatic solid bounded by six equal square edges. So this is your typical dice or your box or your cubes, so or blocks. So the angle between any two adjacent faces being a right angle. So because of the quality of its dimensions, the cube is static form that lacks apparent movement or direction. So whenever you roll over a cube, it just basically stays there in place. It doesn't have any active or any let's say uh un say, um any, let's say, uneven surfaces or uneven edges that enables it to roll. So unless you push it over or unless you throw it or something like that, then it will actually roll or move or stumble. So primary solids examples. So this is more Prometheus. So project for an agricultural lodge. So the spherical shape is actually used to create the impression of an accent impression in in a landscape setting. So Chapel, Massachusetts Institute of Technology. So it's Eero Saarinen and Associates. So the use of the cube, the cone as a base for the shape of the building. So regular and irregular forms. So regular forms refer to those who are related to another in consistent and an orderly manner. So this is where it happens. So you have your equidistant measurements from all sides. So these are your regular forms. Same with the triangle. So you have the equidistant measurements and dimensions from both ends, and same with the square, which you have the 90 degrees from all the corners. So forms can retain their regularity when transformed dimensionally or by addition and subtraction of elements. So from our experiences with similar forms, you can construct a mental model of an original whole even when a fragment is missing and another part is added. So this is very prevalent in design. So even when you have an addition to this, so you'll still recognize the triangle of the original shape of the triangle. So for the last one, so even with the absence of the part or the puzzle, the piece here in the center, you still perceive this as a square. So irregular forms are those whose parts are dissimilar in nature and related to one another in an inconsistent manner. So they are generally asymmetrical and more dynamic than regular forms. They can be regular forms, which can be irregular elements and have been subtracted or added as a result of a regular composition. So with this, you have uh, the combination of forms. In this one, you have the combination of the circle with regards to the triangle. The second one is the irregularity of the shapes and the connection of the two forms, which seems dynamic and asymmetric or asymmetrical. So you can see the inclination of the triangle and the positioning on which the triangle is placed as well. So the last one is the combination of the surface plane and then the composition of round, triangle, and then the square forms. So since we deal with both solid masses and spatial voids in architecture and in design, regular forms can be contained within irregular forms. So in a similar manner, regular forms can be enclosed by regular forms. So with regards to the forms, there is actually no limit as to what we can achieve. So in this, this is very true to interior and architectural design. So here, for example, we'll envision the space to be a land plot in which is surrounded by trees, or this would be the actual land plot or the site development in which you'll be working on. And you will have this approach of having a circular or a very circular plan in the layout. So this can actually be true to any design problems. And then we have transformation of form. So all other forms can be understood to be transform of the primary solids. So variations which are generated by the manipulation of more dimensions or by the addition or subtraction of elements. So you'll also be encountering this in SketchUp or when you're approaching your 3D modeling class. So this is very pertinent, the subtraction, the addition, and the intersection of shapes and forms. So in this, so in this, you have your dimensional transformation. So a form can be transformed by altering one another of its dimension and still retain its identity as a member of family of forms. So a cube, for example, can be transformed into a similar prismatic form through discrete changes in height, or width or length. So it can be compressed into a planar form or can be stretched out into a linear one. So whenever you do drawings or 3D modelings, or maybe later when you're in concept development, you'll be able to grasp the transformation of form with regards to spatial planning, or even to a concept that you really wanted to explore. So with this one, transformative can start with the base, and then you deduct or to create this plane of a wall, or you create or you deduct the space and retain this structural membrane, which might be a beam or any structural components or architectural components. So, subtractive transformation. So, a form can be transformed by subtracting a portion of its volume. So, depending on the extent of the subtractive process, the form can retain its initial identity or can be transformed into a form of another. So, one one example for this would be sculptural forms. So, usually in sculpture, let's say in Renaissance time, you start with a block of marble, and then through subtractive transformation, you'll be able to form, let's say, Venus de Milo, or um, you know, images of the deities and gods and goddesses. So all of those actually start from a block of marble and then carve their way in to have this form and shape. So this can also be very this can also be taken from for concept development. For example, um, you start off with the base framing of a space, and then you adjust to it as you see fit to the demands and the needs of the clients or your potential clients. So additive transformation, so a form can be transformed by the addition of elements to its volume. So the nature of the additive process and a number and the relative sizes of the elements being attached determine whether the identity of the initial form is altered. So this is very visible when it comes to extensions. So, or maybe addition like architectural extensions, or house renovations. This is very there's very much how we experience it, or even with addition to tweaks in forms or design. So this is where it will actually be of use So in addition, let's say for a house, I want an extension of a house to serve as a guest room. So this is where the original form will be altered. All right. So transformation of form. So the dimensional transformation of a cube into a vertical slab, and then you have your, so this is in addition, so you have that, and then you have a subtractive transformation, creating volumes of a space. So basically, with this you're creating voids to add more volume and to create a form in which that is not uh, create a form which is basically an addition and subtraction of shapes. So dimensional forms for dimensional transformation. So a sphere can be transformed into any number of o- ovoid or elliptical forms by elongating it. So with this, in through sketching, I think it's very easy to come about with sketching spheres. But when we do design or let's say AutoCAD drawings, you also have you pinpoint the measurements to create a uniform approach when it comes to dimensional transformation. So a pyramid can be so for the next one, so it would go as would actually be of the same. So when you have a starting base, you can actually, let's say, twist it or transform it into a form that would actually meet with your, let's say, concept or the way you want your design to portray. Lastly, it's also same with the cube. So a cube can be transformed, so you can adjust it according to the scale and to the level of requirements to be met. Okay, subtractive form. So subtractive form is we search for regularity and continuity in the form. So we see within our field of vision. So with subtraction of form, so these are easily recognizable because simple geometric forms such as the primary solids adapt relatively to the subtractive development. So these forms will retain their formal. So this will have their formal. This will have their formal identity, which was once a cube, and then you have portions of the volume that are removed. So same for this one. So you have this formal, this main form in which these shapes or these forms will be subtracted from the base form. So whenever you do subtraction, so this will happen. So there will be well, basically it's subtractive in form, so it will be taken apart from the whole object or the whole shape. So okay, so yeah, other examples as you can see. So this is a series of figures with a varying subtraction when it comes to the space. So you start off with a corner, and then you increase the size of which the form will be subtracted, and then you end up with this a maximized scale in which the form or the shape will be subtracted from. So Le Corbusier comments on. So you have your cumulative composition, your cubic composition, and then your subtracted form. So this is your cumulative composition. So it's an additional form. It's a rather easy type since you add as you go. So it can be completed discipline by classification and hierarchy. So you have cubic composition. So it's basically pure in form. So it's very difficult, and you have to play around with materials and composition to have this. So um, and then you have your subtractive form. So it's very generous on the exterior, and and the architectural will is confirmed. So it depends on what is the brief and what you're trying to portray in your or develop in your design. So additive. So while a subtractive form results from the removal, so additive is when you add. So here, the basic possibilities for grouping two or more forms by have spatial tension. So this type of relationship relies on the close proximity of the form. So it's basically side by side. They usually share a common trait such as shape, color, or material. So you have edge to edge contact, as you can see. So it is unifying by an edge. So this would how it looks like when combined together. So you have your face-to-face contact. So basically, this is a surface. So a certain part of the surface of this plane will be attached or adhered to this form. And then you have your interlocking volumes. So there is an interlocking. So there is a shared relationship. So it doesn't have shared visual traits, but it will be interlocked or interpenetrate each other's space. So organization of form. So you have your centralized form. So a number of secondary forms clustered about a dominant central parent form. So this is where you play the location of the point. So it radiates towards a central form or a central element. So linear form is a series of form arranged sequentially in a row. So they will be equally spaced or sequential or applied sequentially in that manner. So a radial form is a composition of linear forms extending outward from a central form in a radial manner. So radial, so it will be surrounding or around that central plane. So the clustered form is a collection of forms grouped together by proximity and the sharing of a common visual trait. So given they have a visual trait, they have this is very I think typical in housing and developments. So you have they share a common visual trait but are scattered or placed in a contained space. Let's say this is a subdivision, and then you have the house or the townhouses um, grouped in a manner with relation to site development or housing. So grid form is a set of modular forms related and regulated by three-dimensional grid. So the grid system is actually one way of organizing spaces, and also in, let's say, in urban planning setting. So that's why we have cities with for example Colon, which we have a grid form of interconnection of streets there. Okay, so this is your centralized form. So you have the central plane here. So all of it will be intersected by the central point. You have the linear form. So as you can see, this very linear in direction and in characteristics. The radial form, so that they are circulating around this radial area. And then you have your clustered form, which is basically clustering of certain elements in a space. So grid form, so this is also very visible in construction, in engineering, and architecture. So formal collisions of geometry. So when two forms differing in geometry orientation collide and interpenetrate each other's boundaries, in which will vie for visual supremacy and dominance. So the following forms can evolve. So you have your circle and your square. So the dominant forms. So two forms can subvert their individual identities to create a composite form. So you have the circle. So circle in a square, so they are interpenetrate, so one or the other is basically in the same plane. So the circle is not within the square, but they are interpenetrate, so they have equal spacing, so therefore you have this shape. Same with this with the rotated grid as well. So one of the two forms can receive each other totally within its volume. So this is a collision in where the shape is within that of the dominant shape. And this one, the two forms can retain their individual identities but sharing an interlocking portion of their volumes. So this one, you can still recognize the square and then the circle, but they are connected by this portion of their volumes. So same well for this. Formal collisions of geometry. So two forms can separate and be linked by a third element. So therefore, you have a square and a circle which can be linked through these linkages of a line. So therefore, creating a connection. So same with this one. So formal collision, so to accommodate or accentuate different requirements of interior space and exterior forms. So this is where architecture and interior lie with each other. So this is to have a cohesiveness in the space and the transition of the spaces. So formal collisions, so you have to express the functional or symbolic importance of a form or space within its context, and it is also to generate a composite form that incorporates the contrasting geometries into a centralized organization. So this could actually symbolize that of a architectural building. Therefore, you have, let's say, an interior fountain or interior lobby that's rounded in nature. So this can be a possible formal collision of geometry in which the interior space is actually an opposite shape or form of that of the external or the architectural space. So it can be also expressed in possible land or site development in relation to architecture. So this is, let's say, this would be the plot of land that you will be owning, or this is the plot of land where you'll be building on, and then you wanted to build a house that is, uh, let's say, one fourth of that of the space. So you are planning to create an uh, unique development. So you have this space that's say for landscaping or farming, and then you have this for your residence. So these are basic forms that you might see or you might encounter in real life, but this is simplified form in which can be understood with the aspect of geometry. So, other collisions is to inflect a space towards a specific feature of a building. So, and then to carve a well-defined volume of space from a building form and to express and articulate various constructional or mechanical system within a building form. So I think now we have very progressive and forward-thinking designs that the limit between geometric and organic shapes are very thin, or sometimes they overlap each other. So I think an idea on how to compose or to combine um, would actually uh, would actually improve us or improve the way we think. So, formal collisions of geometry. So, this is to enforce a local condition of symmetry in a building form and to respond to contrasting geometries of topography, vegetation, boundaries, and existing structures of a site, and to acknowledge an already existing path of movement through a building site. So, this is very prevalent when it comes to design. When we are considering um, the natural environment and with regards to any built environment. So we have to be considerate of the areas or spaces that we'll be building, and what requirements we are to meet from the client's potential potential needs. So formal collisions of geometry. So a form can be articulated by differentiating adjoining places with a change in material, color, texture, and pattern. So developing corners as distinct linear elements independent of abutting planes, and removing corners to physically separate neighboring planes, and lighting the form to create sharp contrast in tonal values along edges and corners. So this is an example when it comes to differentiating. So with the application of material, color, and texture, and developing corners as distinct linear elements uh, from adjacent or neighboring planes. So treatment of corners. So since the articulation of a form depends to a great degree on how surfaces meet each other, so corners, so these edge conditions are resolved and critical to the definition and clarity of form. So while a corner can be articulated by simply contrasting the surface of adjoining planes or obscured by the layering, the adjoining, or an optical pattern. So in this one, the corner was articulated through the joining of this, so kani, the corner. So you have difference of surface qualities of the space. So at so for a corner to be formally active, there must be more than a slight deviation in the angle between adjoining planes. Since we constantly search for regularity and continuity within a field of vision. So this is very prominent in anamorphic designs. If you can actually look at what anamorphic would perceive. So this is actually a design in which it is with regards to the continuation of an eye or visual perception, in which when you look into a space, it seems not discontinued, but when you perceived it in a, let's say, in a specific area, you'll see it as a whole or in a continuing manner. So at one point, do these formal deviations become an acute angle, and then a segmented. So you have your acute angle, so the different angles, then your right angle, a segmented line. So from um, uh, let's say a straight line with slight deviations with regards to where we fold or create a segment, and a circular segment, so it's a change in the line. So here you have a straight planar line, and then on there is an undulation that is developed through different stages. So corners define the meeting of two planes. If the two planes simply touch and the corner remains unadorned, the presence of the corner wall depends on visual treatment of the adjoining. So with this one, so you have these two surfaces of the same material uh, meeting at the corner. So you have this termination in where this point will meet. So a corner condition can be visually reinforced by introducing a separate or a distinct element. So um, this is element articulates the corner as a linear condition, so it defines the edge. So sometimes, let's say in construction or in design, we use the treatment of corners to actually accentuate that of the design. So this is a different, it's a as a treatment in which it actually avoids the corner termination and rounded it up to prevent, let's say, chipping or for people to actually be bumped with this sharp edge. So if an opening is introduced to the one side of the corner, one of the planes will appear to bypass the other. So um, and the opening diminishes the corner condition, so it weakens the definition of the volume within the form and emphasizes the planar qualities of the neighborhood surfaces. So with this, since there's an opening introduced, so it seems or it visually percepting that this would actually bypass this wall, so visually. So if neither plane is extended to divide the corner or a volume of space is created to replace the corner, this condition deteriorates the volume of the form. So allows the interior space to leak outward and clearly reveals surfaces as planes. So with the absence of this corner, so it actually reveals the surfaces of these planes. So Rounding off a corner emphasizes the continuity of bounding surfaces of a form, the compactness of its volume, and the softness of its contour. So this is, I think, prevalent when it comes to, let's say, surfaces in which you want to avoid the sharp or the sharp edges, or to maybe um, emphasize the continuity of the line. So this is very tricky when it comes to, let's say, glass application, since having this corner without any section is a challenge construction wise, or in development. So but in its whilst we're still in the concept and the design elements, so these is a very the continuing or the rounding of the corner actually adds a feminine quality and a softness to the design. So integration of different forms, so building as a landscape. So um, for the hair, so you have your base plane. This is our horizontal plane as a figure on a contrasting background. So as discussed in the previous discussion. So you have your elevated base plane. It's a horizontal plane elevated above the ground and establish a vertical surface along its edges. So this is usually um, uh, considered like or perceived like a platform. So a depressed base plane, so our horizontal plane depressed into the ground. Ground plane utilizes the vertical surfaces of the lowered area to define volume. So this actually creates depth to a space with this hollowing out of the plane. And then you have your overhead plane. So our horizontal plane located overhead defines a volume of space between itself and the ground plane. So this is an example of an overhead plane. So it's basically a it feels like it's a roofing or a shade or a surface or a protection from that, if when it's over or hovering above the ground plane. So now we'll be moving forward to space. So form and space. So space constantly encompasses our being. To the volume of space we move, we see forms, hear sounds, feel breezes, smell the fragrances, and of the flower in the gardens in bloom. So it is a material substance like wood or stone, yet it is an inherently formless vapor. In its visual forms, its dimensions and scale, and the quality of light, all of these qualities depend on the perception of the spatial boundaries defined by the elements of form. As space begins to be captured, enclosed, molded, and organized by the elements of mass, architecture or design or interior design comes into being. So, okay. So this is a visual perception. Okay. So the symbiotic relationship of forms of mass and space in architecture and interior design can be examined and found to exist at different several scales. So at each level, we should be concerned not only with the form of a building but its impact on the space around it. So that's why we consider the built environmental design for us to be to go past to the boundaries of that of the four walls that we are entrusted with. So at an urban scale, we should carefully consider whether the role of a building is to continue the existing fabric of a place, so it forms a backdrop for other buildings, a defined positive urban space, or whether it might be appropriate for stand free as a significant object in space. So in any design problem or any design solution, for us, we have to consider and the neighboring environment, the backdrop, and then even up to the fabric of the being of the space. So whenever we, let's say for architecture and design, so whenever we do buildings in, let's say, remote areas where we are surrounded by nature, for us is to consider what aspects should we embody that of the natural existing environment. So it's same bodes with interior design. Whenever we are faced with this challenge of um, adapting and to developing a space within the proximities of a built environment is for us to consider its relationship as one and as a whole. So um, as interior and architecture plays into the development of urban design and built environments, we have to consider the limitations and the scope of each craft or each profession. So at the scale of the building site, there are various strategies for relating the form of a building to the space around it. So a building can form a wall along an edge of the site and begin to define a positive outdoor space. So you have to merge its interior space with the private outdoor space of a wall site. So 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 enclose a portion of its site as an outdoor room and shelter it from undesirable climatic conditions. And D, you have your surround and enclose a courtyard or an atrium with its volume. So these are layout, or let's say strategies, in considering the use of space, the use of interior space and the built environment in combination to design composition. So um, this example is a standard as a district object in the space and dominate its site through its form and topographical positioning, so as an extroverted scheme. So this is very prevalent in government spaces in which you have a central building or a central element in which would go out to an extroverted scheme. Therefore, it's a public space still. So for this one, for letter F, so stretch out and present a broad face to address a view, terminate an axis, or define an edge of an urban space. So as this is a great example of this as well is um, let's say an engineering building, the engineering building of San Carlos, in which you have the whole vastness of the space, in which directs your view upon the entry. So another example would be the capital of Cebu, in which it it's very prevalent in government buildings and institutions, in where the vastness of the space or the broadness of the face of the building or an establishment actually addresses as a view, or it defines an edge to an urban space. So for the for letter G, so you stand free within its site, but extends its interior spaces to merge with private exterior spaces. So this is where the combination of your architecture, interior, and landscape design will actually stitch in. So you have the elements of the architectural environment, which you have your structural and basically the framing of where the space would start, where the interior space would start, and the treatment of the interior spaces, which bleeds out into the architecture, into the landscape. So this is a free flowing layout or a free flowing plan. So for H, so you have stand as a positive form in a negative space. So this one also, this is usually shown in housing and developments. So, this degree to which a spatial and visual continuity is maintained between an elevated space and its surrounding. So, the first is the edge of a field is well defined, visual and spatial continuity is maintained, and physical access is easily accommodated. So, visual continuity. So with this one, there is a visual continuity up to this area. So there's a different play on the heights, but you can still maintain or gain access to it. So it's very accessible by your line of vision. And then for the second, so visual continuity is maintained, spatial continuity is interrupted, but physical access requires the use of stairs and ramps. So with this, you still have the visual continuity. So there is still visual cues that would direct you, although it is in a different spatial level. So and then it is interrupted now with this level, so the height, so which we can be addressed with stairs or ramps or elevators or in access. And then for the third, this visual and spatial continuity is interrupted. The field of an elevated plane is isolated from the ground or floor plane, and the elevated plane is transformed. Sorry. So the visual and spatial continuity is interrupted. The field of elevated plane is isolated from the ground of the floor plane, and is transformed into a sheltering element for the space below. So as you can see, so there is a separation as to the visual spatial continuity. So and then therefore this elevated plane is then enclosed into a shelter. So the degree of spatial continuity between a depressed field and the raised area surrounding is depends on the level scale of the level changed. So with this one, you still have for the first, so you have the visual continuity of through and through. So there is no interruption as to the perception of the whole space. I compared to this one. So the depressed, so this level of the depressed of the field is still entails you to have a full visual continuity for the rest of the space. For the one below it, so the increasing depth of field weakens the visual relationship. So as you can see, if you were like of a smaller scale or frame, this would be a problem, or this would actually interrupt your view. The increase of the depth of field weakens its visual relationship with the surrounding space. So, and its division as a distinct volume of space. So, given that we have increased the depth of the field, so it will your line of sight will actually be constrained to this one, giving this as a separation of space already. So, creating a step or terraced or ramp transition from one level to the next helps promote continuity between a sunken space and the area of the rises around it. So with that, so whenever you're saying you want to go to a sunken space, so you still have the level of continuity when you're still going down. So from here, you still have level of view from there. Okay. So if vertical elements, linear elements such as columns or posts are used to support the overhead plane, they will aid in visually establishing the limits of the defined space without disrupting the flow of space through the field. So um, the vertical elements such as these, so help support the overhead plane. So they will aid in visually establishing the limits. So the limits that are entailed in this drawing is on these four corners. So whenever you remove the, let's say, the vertical linear elements, it would actually uh, it will not disrupt the flow of the space throughout the field. So similarly, if the edges of the overhead plane are turned downward, or if the base plane beneath it is articulated by a changed level, the boundaries of defined volume space will be visually reinforced. So with this one, so there is a change in level. So the visual volume of space would actually reduce. And the other opposite end, so the vis the visual um, volume will actually increase given it is depressed to the plane. So you have examples of planes. So you have your single vertical plane. So as a single vertical plane articulates the space on which it fronts. So this one, single vertical plane. And then L-shaped plane. So an L-shaped configuration of planes generates a field of space from its corners. So this is where your L-shaped plane would look like. So in this is in perspective, in orthographic, and in plan. So you have your parallel planes, your two parallel vertical planes define a volume. So this is your two parallel planes. so which defines the volume of the space. So basically, it constrains this other side while opening up the two ends. So as described here, portrayed there. Your U-shaped plane, so a U-shaped configuration of vertical spaces defines the volume of a space, the space that is oriented primarily towards the open end of the configuration. So with an open end of the configuration, so this is the enclosing space, and this would be the open end of the configuration. So four planes or your closure, so four vertical planes establish the boundaries. So boundaries of an introverted space and influence the field of space. So whenever you have four planes, so basically it's enclosing the space within a box. So um, openings. So these are an application of different um, subtract yeah subtractions in the space. So um, openings lying so with regards to the openings in the space, so openings lying wholly within the enclosing space do not weaken the edge definition nor the sense of enclosure of the space. So given in this plan, so we have four enclosed walls within the plane, and then the form of the space remains. So with this is a typical interior plan. So you are enclosed with these four walls, therefore but you still have the opening. It doesn't really take away from that of the space. So the perception of it to have four walls remains the same. So this is very prevalent in any interior and architecture. So whenever there is openings, it doesn't really subject that it lacks the form or the spatial quality. So it's still enclosed in a space. It might be actually square in plan, but it's actually let's say addressed, or it's actually adorned with or have a construction of four walls or enclosure. So same with this. So we have the visual perception that it's open, but it's still in construction a closed plan. So openings located at the edges of the closing planes of a space visually weaken the corner boundaries of the volume, while these openings erode the overall form of a space. So they also promote its visual continuity and interaction with adjacent spaces. So for example, one example would be the application of sky roof. So um, these openings actually erode the space. It takes away from the space, but it's still a continuation of the rest of the spaces. So just because this is open here doesn't means that the line or the construction ends here. So it's actually still in a part of that space. So it plays a role in the space. So opening between the enclosing space of planes of space visually isolates the planes and articulate their individuality. So as these openings increase in number and size, the space loses its sense of enclosure, becomes more diffuse, and begins to merge with adjacent spaces. So the visual emphasis on the enclosing planes rather than the volume of space defined by the planes. So this is very typical when we're adhering to open planning. So this is typically brought about in office design, in interior architecture, or interior architecture in with regards to landscape. So especially now that we are very much about opening up to the space or to the outdoor, or in taking in the environment as a means of design, as a design in application and inspiration as well. Um, so as you can see, so these are examples of spaces in which with the absence of the actual planes, So there would be a limitation of the application of walls, but there is still a perception of enclosure. So for this one, so in a let's say in a solid plane, so this would actually form as this enclosure for the space. With this one, you're taking visual cues that this would be your plane enclosure, and you have this limitation around even in the absence of an actual wall. So same bodes for this one, in which the storage space will serve as your wall or your plane, and you have this divider to actually highlight that more regarding the separation of the space. Another idea in which openings between and closing another idea about this treatment is the use of furniture and furnishings when it comes to separation of space. Especially, this is very visible in office spaces or in large spaces in which we have to section without actually placing fixed partitions. So an example of House Berlin building exposition, in which there is an open planning and there is a free interpretation or free movement of a space. So as you can see, this is also prevalent in co-working spaces and on how office furniture are laid out and how places can determine its function as well. So this is very visible in planning. So for individual spaces. Okay. So two spaces may be related to each other in several fundamental ways. So it's a space within a space. So a space may be contained within the volume of a larger space. Interlocking spaces, the field of a space may overlap the volume of another space. So these are examples of a space within a space. Um, and then a space within a space, and then an interlocking. So with this, you have the interconnectedness of the space, in which this would serve as your meeting area or huddle room in interconnected to that of the whole office. So this is not a separation, but it serves as a part of the whole. For this one, it's a counter, or it's typically seen in corporate or in commercial setting, in which tenants are are awarded with a space for their own, let's say, products and services. So this is actually independent or an individual space within a larger context of the scale. So adjacent spaces, so two spaces may abut each other or share a common border, and then space linked by a common space. So two spaces may rely on intermediary space for the relationship. So a large space can contain a smaller space within its volume. So visual and spatial continuity between the two spaces can be easily accommodated, but the smaller contained space depends on the larger enveloping space for its relationship for the exterior environment. So these are examples. So this is an example of a larger space of how a smaller space contains in a larger space or in a larger setting. So with this one, you have the grandeur. So we're just showing bars and bar designs, since these are very notable in design and commercial or hospitality setting, with the vastness of the space, and then the a smaller volume, which actually contributes to the entirety of the space. So this is an example as well. Okay, so to endow itself with a higher attention value, the contained space may share the form of the enveloping shape, but be oriented in a different manner. So this is another take on the shape. And then the contained space may also differ in form from the enveloping space in order to strengthen its image as a freestanding volume. So this is usually treated in architectural or interior installations and in design and in art and sculptural design as well. So interlocking of spaces. So an interlocking spatial relationship results from overlapping of two spatial fields and emerging of a zone in shared space. So this is very visible in a of combination of spaces in in which um, in which would develop a common denominator. So resulting in a configuration of two interlocking spaces. So the interlocking portion of the two volumes can be shared equally by space. So this is how the um, moving forward. So we have an interlocking spatial relationship results in overlapping into spatial fields. So we have examples here on how the interlocking portion of the two volumes can be shared equally by the space. So these are the interlocking portion of two volumes. So the second row would be the interlocking portion can merge without one of the spaces and become an integral part of its volume. So it is more or less an addition, which is adds on as part of a whole. So in this one, so the interlocking portion can develop its own integrity as a space that serves the link between two original spaces. So in this composition, uh, these volumes or these spaces on the side would act as individual or have their own integrity, while the interlocking portion can will be or will serve as a linkage. So usually this is portrayed in a shared space or a linkage or a bridge or let's say in other residential, possibly a courtyard. So adjacent spaces. So adjacency is the most common type of spatial relationship. So it allows space to be clearly defined and to respond and in each in its own way. It responds to a specific function or symbolic requirements. So the degree of visual and spatial continuity that occurs between two adjacent spaces depend on the nature of the plane that both separates and binds them together. So with regards to adjacency, so this is very typical when it comes to determining the function of the space in interior design. We have to establish what the functions are and how they correlate to each other. So, for example, in an office setting, um, the admin or the administrative department would correlate with finance or should correlate with corresponding offices or departments. So once they have, let's say, a linkages with regards to the functions of the space or the work, then therefore you address them with adjacency or they should be placed side by side. So with separating the plane, so it may limit the visual and physical aspect between two adjacent spaces. Therefore, it reinforces the individuality of space and accommodate their differences. So this is very typical in interiors. So let's say in interior or built environment spaces. Let's give it an example that this space would serve as the master bedroom, and then this would actually be the master bed bedroom or master bathroom. So there is a separation of the space, and this linkages would actually denominate the function of the space. So given this would be the common area, thus that termination there at the center. So um, in this second row, so it appears as a freestanding plane in a single volume of a space. So this is where your room dividers or room partitions take place. It's basically um, separating two adjacent spaces without enclosing it out. So you still have the common common elements of that of the wall or the ceiling and the floor, with a barrier or a minimal barrier that separates two areas or two spaces. So the third one is to be defined with a row of columns that allow a high degree of visual and spatial continuity between the two spaces. So as portrayed in interior space, it gives you the visibility that you need, but still have the perception of the separation. So it doesn't. So as you can see, it has a visual um, denomination that is a separate wall or a separate space without making it too closed out. So there is still an adjacency or a correlationship between two spaces. So spaces linked by a common space. So two spaces that are separated by a distance can be linked or related to each other by a third or intermediate space. So the visual and spatial relationship between the two spaces depend on the nature of the third space on which they are commonly bond. So for example, this would be the inner lobby of a hotel, and this would be the exterior environment or the landscape or urban street na. So what may be another example of linkages, maybe this would be a revolving door in which a passerby would have to go around or go through this door for access. So this intermediate space can differ in form and doesn't have to have the same denomination as both spaces. So these can vary, and this doesn't only apply to square or enclosed na spaces. So two spaces as well as the intermediate space can be equivalent in size and shape and for a linear sequence of spaces. So this is also, I'll just pull out resources that maybe you'll be familiar. So this is how we perceive cubicle spaces. So you have and even condominium. So you have equivalent in size and shape and form a linear sequence of spaces. So when you view condominium units, they're more or less repetitive in form and repetitive in shape and size, but would have various shape in depending on the, let's say, unit capacity, or let's say it's a three bedroom, it's a two bedroom, but there is a repetition in the sequential of the space. The intermediate space can itself become linear in form to link two spaces that are distant from each other, or join a whole series of spaces that have no direct relationship to one another. Um, so this can be in a form of a bridge or a passageway. So given this would pertain to a different city in which you have your bridge as the linkage, and then you have this entry area. So we have two entry points, and then this bridge would actually be the linkage uh, that bridges the relationship from this area and this area. So the inter the in, the lastly and then the intermediate space can, if large amount, become the dominant space in the relationship and be capable of organizing a number of spaces about itself. So a good example would be to have this in a landscape approach. So sometimes the unifying factor is the outdoor environment and tying up everything in its adjacent to it uh, towards the space. So for example, we'll use Fuente Osmeña as the intermediate space. If given the size and the proportion, it actually holds, it has a dominant relationship between the adjacent buildings around it. Okay. So lastly, we have color and value. So color and value is a phenomenon of light and visual perception that may be experience in terms of an individual perception of hue, saturation, and tonal value. So, color is the attribute that most clearly distinguishes a form from its environment. So, it also affects the visual weight of a form. Okay, color L value. So, color is a pigment reflected in an eye's invisible light. So, it has properties such as hue, value, chroma, or intensity. So, hue is the distinguishable color, value is the lightness or the darkness of the hue, and the chroma or intensity, this is where the strong and the weak colors will appear. So you have your combination of colors. You have your primary, which is the main three colors, and then you have your analogous, so your adjacent colors, your secondary, so that of the primary derived from that of the primary, and then your complementary, so the one um direct opposite of that of a certain color, and then your split complementary, and then the square, so this is a square combination, and then you have varying hues, so hues is the purest form, tint, the lightness, and then shade, the darkness of the hue. So color have design different names for each colors, shades or tints. So this actually varies in every brand or um, any product that deals with color. So in graphics, graphic designers use codes such as hex codes, your RGBs, your HSL, and your CMYK. So this is very the use of Pantone colors, which actually derives the the art of categorizing color, and also in architecture and interior, in which paints as much paint development goes, they have specific codes and colors in which it is presented to a designer or an architect. So some samples. So color and value. So with color and value, we deal with psychology of colors, and then and how colors evoke in spaces. So for yellow, you have cheerful or warm. So it's most likely to strain eyes because of fatigue. So this is well should be well applied into areas where there is active participation or traffic, and also we have blue, so this is a color most preferred by men, so it's related to calmness and serenity, and it's used in office spaces, but I think there is a gradual shift with regards to color application in an office space, and then it also curbs appetite and is associated with water and peace. So red evokes strong emotions. It encourages appetite. Therefore, this is where you see mainly in restaurants. And then passion or intensity, and symbolizes love. Okay. So colors can help separation and help with the separation of elements, and it levels for identification. So color exudes mood of being sunny or warmth, and colors provide experience and a feeling of space. So colors from materials help emphasize concepts or tranquility. So whether it will be smooth or warmth, so warmth of the wood and the smoothness of concrete or stone. And then warm colors help promote appetite as well. And colors used together with lighting and form creates an interesting design feature or accent. And then also, colors signify actual visual temperature of a space or water. Or in an example, cool colors signify cold water temperature. Um, thank you. So, attach our references with regards to our topics, and hope to see and discuss with you guys the forms and the elements of design. Thank you.